Hello students, we have studied derivatives and differentiation. Today we are going to study differential equations. It has applications in maths and physics as well. It's an important topic, so watch the video till the end. So basically any equation which involves derivatives of any order is called a differential equation. An equation involving derivative one or more of the dependent variable with respect to the independent variable or variables is called a differential equation. Simple example, x dy by dx plus y equal to 0. Remember, dy by dx can be written as y dash, and henceforth for y d square y by dx square we can write y double dash, and so on for the higher order derivatives. So any equation which has derivative in it is called a differential equation. Now, a differential equation involving derivatives of all dependent variable with respect to only one independent variable is called an ordinary differential equation. Like here it is given, y is a dependent variable and x is the independent variable. Only one independent variable is there. It's an ordinary differential equation. But suppose you have a differential equation, it involves derivative with respect to more than one independent variables. It is called partial differential equations. Like the example given over here, d square u by dx square minus 1 upon c square d square u by dt square equal to 0 means over here there are two independent variables x and t. So it's a partial differential equation which you will study further. In today's video we are going to study how to solve a differential equation, but before that you should know what is the order and degree of a differential equation. It's important, try to understand it properly. The order of a differential equation is the order of the highest order derivative in it. That means if you have y dash, y double dash, two derivatives, and y double dash is of highest order, so it is, the order is 2. Degree is the power of that highest order derivative. That means, for example, given over here d cube y by dx cube plus x square into d square y by dx square whole cube equal to 0. Now don't get confused in these type of examples. First of all, check which is the highest order derivative. It is d cube y by dx cube means order is 3. And you have to check the power of that highest order derivative only. What is the power of it? 1. So the order is 3 and power and the degree is 1. Now order and degree, I have written if defined. We will see further that sometimes degree might not be defined also. So order and degree of a differential equation are always positive integers. That is very clear. Now the degree of a differential equation is undefined when the equation cannot be expressed as a polynomial of its derivatives. Especially, that means, see, you know what is a polynomial, correct? Like very simple example, you know that a1x plus a2x square and so on, that type of equation you call a polynomial. Now polynomial of derivatives, if the given equation cannot be expressed as a polynomial of its derivatives, then the degree will not be defined. When this will generally happen, the rule of thumb is generally when you have trigonometric function, like say derivatives inside the trigonometric function means cos of y dash, sine of y double dash, or logarithmic functions log of y dash, exponential function e raised to y dash, e raised to y double dash. In these type of cases you cannot write in the form of polynomial of derivatives. So the degree will not be defined. So if a differential equation contains such non-polynomial functions, its degree will not be defined. It should be a polynomial equation in its derivatives. Correct? I have given a simple example over here. Dy by dx plus sine of dy by dx is 0, but sine of dy by dx, so it is not in a form of a polynomial, so the degree is not defined over here. We will take some more examples to understand this concept. We will take some examples which will make this concept very clear, order and degree of a differential equation. In the first equation given over here, you can see the highest order derivative is d4y by dx4, means order is 4. And what is the power of that d4y by dx4? It is 3. So the degree is 3. Simple. Second example, you have d square y by dx square plus 3 into dy by dx whole cube is equal to x square into log of d square y by dx square. Now see over here, the highest order derivative if you see the whole equation, it is d square y by dx square. So order is 2. But the degree is not defined again because the derivative is inside a log function also. So obviously it is not expressed in the form of polynomials. So not defined. Third case, you can see highest order derivative is d square y by dx square. So the order is 2. And what is the power of d square y by dx square? 1. So the degree is 1. See, here also sign is there, but sign of x square, sign of derivative is not there. So don't get confused in it. If sine, log, exponential function of derivative exists, then degree will not be defined. Correct? Then next one, you have dy plus xy minus cos x dx equal to 0. Now what you can do is try to convert in dy by dx form. So your dy by dx, if you convert it in that form, you will be getting the equation, and dy by dx is first order, so order is 1, and the power of it will also be 1, so the degree is 1. Next one, e raised to d square y by dx square plus sin x into dy by dx equal to 2. Highest order derivative is d square y by dx square. So obviously order is 2. But derivative exists for the exponent function. So the degree will not be defined. Some more examples for order and degree. In the first example given over here, you can see it is very clear that y triple dash means the order, highest order derivative is of order 3. So order of the differential equation is 3. But degree does not exist because sine of y dash, derivative is there in the sine function, that means a trigonometric function. Second example, the highest order derivative is 3. Again over here degree is not defined because derivative is there in the cos function. Next example, highest order derivative is 3 d cube y by dx cube, and what is the power of it? 1. Power of d cube y by dx cube. So the degree is 1, order is 3. Next example, highest order 2, so d square y by dx square, so order is 2, but the derivative exists inside the log function, so degree is not defined. Same with the next example, derivative exists inside the trigonometric function, so the degree is not defined. But the order of the last example, cos of d cube y by dx cube, that means the highest order derivative is 3, so order is 3, but the degree is not defined. Next example also, you have to determine the order and degree if it exists of the differential equations given over here. Sometimes they might not be given directly. So you need to first of all make some transformations and then obtain the order and degree. So in the first example over here, you can see that you are given over here y is equal to 2 into dy by dx whole square plus 4x dx by dy. Now over here second term has dx by dy. So first of all you try to make it in a proper differential equation of the type dy by dx. So dx by dy is 1 upon dy by dx. When you simplify the equation as shown over here, you will be getting over here, the order obviously is 1, but the power of that highest order derivative is 3. So degree is 3. So by chance if you had made a mistake, not converted it, you will not get the right degree. So order 1, degree 3. Second example, similarly over here on the right hand side on the second example, x plus y double dash whole square is given. So first you need to open the bracket, open the square. After opening the square, when you try to simplify and bring the just simplify and try to obtain the order and degree, you will be seeing that d square by dx square, that means y double dash, that is the highest order derivative. So order is 2 and the power of that highest order derivative is 1. So the degree is 1. So you need to simplify the given equation. Example 3. In here the first case which is given, it is d cube y by dx cube minus dy by dx raised to half equal to 0. Now always remember, whenever the power over here is given in this form, you need to eliminate the radical sign. You need to make it a proper power. That means the derivative should be raised to an integer. So what we do is we just square both the sides. So if we square both the sides, what we get is d cube y by dx cube whole square is equal to dy by dx. Now you can say that the order is 3 and the degree, that means the power of the highest order derivative, is 2. So the degree is 2. So order 3, degree 2. Similarly, in the second example, again you need to eliminate the radical sign. It is 3 by 2. So again you square on both the sides. After squaring, you will be getting the order 2 and degree 3, because d square y by dx cube, that the maximum power of that is 3. So degree is 3. You can refer to the YouTube short on order and degree of a differential equation. Now the next topic is general and particular solution of a differential equation. A differential equation's general solution is a family of all possible solutions that contains an arbitrary constant for each order of the equation, while a particular solution is a specific solution obtained from the general solution by assigning unique values to these arbitrary constants. Take a simple example to understand this. Suppose I have a differential equation y dash is equal to 3x square. Then what will be its solution? From y dash, if I want to obtain y, you know you need to integrate. So integrating both the sides, you will be getting integral of y dash, that is y. 3 into integral of x square. So it will be 3 into x cube by 3 or x cube, plus some constant c. So y is equal to x cube plus c is the general solution. But suppose if I can write any value for c. Suppose if I write y is equal to x cube plus 5, then it will become a particular solution, where the value of c has been taken as 5. So when the arbitrary constant of the general solution takes some unique value, then it will become a particular solution. I think it is clear. Now also remember, as I said in the definition, that arbitrary constant for each order of the equation. That means, for example, the number of arbitrary constant in the general solution of a differential equation of order 4 will be 4. That will be 4 arbitrary constant for fourth order differential equation. But for the same equation, the number of arbitrary constant in the particular solution will be 0, because all constant will be assigned a value. There will not be any arbitrary constant. So the number of arbitrary constant for that particular solution will be 0. Next example, verify that the given function is a solution of the corresponding differential equation. So now what is the function y given to us? Y is equal to root of 1 plus x square. So first thing is you need to obtain y dash. So differentiate on both the sides. You know derivative of root x is 1 upon 2 root x. So derivative of root of 1 plus x square be 1 upon 2 root of 1 plus x square into derivative of x square, which is 2x. So y dash is equal to x upon root of 1 plus x square. Correct? Now see, the equation given, differential equation given in the question on the right hand side is y dash is equal to xy upon 1 plus x square. Correct? So from this you know that y dash upon y, you just divide both the sides by y. That means what you will be getting is y dash upon y will be equal to, on the right hand side, x upon root of 1 plus x square divided by root of 1 plus x square. That means root of 1 plus x square into root of 1 plus x square is 1 plus x square. So when you simplify it, you will be getting y dash is equal to xy upon 1 plus x square. Simply you need to bring the right hand side from the left hand side. So you can say you have checked that for the given equation, the differential equation is y dash is equal to xy upon 1 plus x square. Next example. Verify that the function y is equal to a cos x plus b sin x, where a and b belong to R, is a solution of the differential equation y double dash plus y equal to 0. Same technique. First of all, you have the function y, differentiate both the side, derivative of cos is minus sin, derivative of sin is cos. Now what do you want to bring? Y double dash plus y. So now just check your y double dash. Y double dash means you have to take one more derivative. Remember, in this you need y double dash means take derivative of y dash. Again, when you differentiate y dash and simplify it, you will be getting y double dash is minus of a cos x plus b sin x, which is nothing but minus y. Bring that minus y on the left hand side. So it is y double dash plus y, which is equal to 0. So you have verified it. Next example, verify that the function x plus y is equal to tan inverse of y is a solution of the differential equation y square y dash plus y square plus 1 equal to 0. So the same technique, first of all, the equation given over here is x plus y is equal to tan inverse of y. So take the derivative, differentiate on both the sides. Derivative of x is 1. Derivative of y with respect to x will be dy by dx. On the right hand side, you have tan inverse of y. So first of all, the derivative of tan inverse is 1 upon 1 plus y square. Derivative of tan inverse of y is 1 upon 1 plus y square into derivative of y, which is dy by dx. So just don't forget this, because you have to multiply by derivative of y, which is dy by dx. So when you simplify this, just this is simple simplification. When you simplify this and open the bracket, you will be getting 1 plus y dash plus y square y dash is equal to y dash. So on simplification, you get the equation which you want, differential equation, y square y dash plus y square plus 1 equal to 0. Now we are going to study a very important method called the variable separable method to solve first order first degree differential equations. So first of all, consider a first order first degree differential equation. So its type will be dy by dx is equal to some function f containing variables x and y. Now by definition, if suppose your fxy can be expressed as a product of some gx into hy, that means a function of x into a function of y, then it is called a variable separable type equation. Simple language, suppose if you are having differential equation dy by dx is equal to minus 4xy square. What you need to do is you just bring the terms having y on one side and x on another side. So the given equation I can write as dy by y square is equal to minus 4x dx. The working rule or the trick is, first just segregate the terms having x and y, then integrate on both the sides and you will be getting the general solution. Correct? And obviously for the particular solution, you put the given values of x and y, some condition on x and y will be given and you can get the constant c. Example, for the given differential equation, you need to find the general solution. The differential equation is e raised to x plus e raised to minus x into dy minus e raised to x minus e raised to minus x into dx equal to 0. So as I told you, the trick is just bring the terms of having x on one side and y on another side. Correct? So over here I can write dy is equal to dx into e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Now next step is you have to integrate on both the sides. Now see, integration, we have already studied integration. In that I gave you very important formula which is very helpful in some of the examples, and that is whenever you are having integral of the type f dash x upon fx, means down you have the function and in the numerator you have its derivative, then its integration is ln, means log with the base e mod fx plus c. We can use this very well over here. We have done these type of examples. You need to integrate both the side. Now for integrating the right hand side, if you consider your function fx as e raised to x plus e raised to minus x, what is its derivative? Derivative of e raised to x is e raised to x and derivative of e raised to minus x is minus of e raised to minus x. So basically your right hand side function is of the type f dash x upon fx. So its derivative is ln of mod of fx. What is your fx? E raised to x plus e raised to minus x plus c, which is the constant of integration. So see how easily you can get the integral. Suppose if you don't want to use this direct formula, then obviously you can use a substitution method. You can substitute your e raised to x as t and so on, and then you can find the derivative. But this is a very important trick by which you can find the integral. Example 8. For given differential equation, find a particular solution which satisfies the given condition. The differential equation is x into x square minus 1 dy by dx equal to 1 and the condition is y is equal to 0 when x equal to 2. Now just remember, in the previous example we had found the general solution. So it had the constant of integration c. For particular solution, you first find the general solution and then find the value of that constant c for the particular solution. That is the difference. So the given differential equation, The trick is, first just segregate the terms having x and y, means bring the terms having x on one side and y on another side. So it will be dy is equal to dx upon x into x square minus 1. Integrate on both the side. Integral dy is equal to integral dx upon x into x square minus 1. Now for integrating the right hand side, we have studied the partial fraction method. So if you have these type of factors in your denominator, you can definitely use the partial fraction method. You can refer to the video on partial fraction method. So now what is that? Dx upon x into x square minus 1 can be written as dx upon x into x minus 1 x plus 1. For the partial fraction method, you need to find constants a, b and c. How? Which satisfy the given condition. A upon x plus b upon x minus 1 plus c upon x plus 1. That means when you take the LCM, it will be a into x minus 1 x plus 1. It is a into x square minus 1 plus b into x plus 1 plus c into x minus 1. So what was the partial fraction method? You compare the coefficients of all the terms on both the sides. So first of all, if you compare the coefficient of x square, on the left hand side the coefficient of x square is 0 because dx, that means only it is 1 into dx, no other term is there. So coefficient of x square on the left hand side is 0. On the right hand side, coefficient of x square is a plus b plus c. So a plus b plus c is 0, that is the first equation. Then when you compare the coefficients of x, again on the left hand side there is no term involving x in the numerator, so it is 0. But on the right hand side, terms involving x are b minus c. So b minus c is 0. This is the second equation. Now you compare the constant term. On the left hand side the constant term is 1. So it is 1, and on the right hand side the constant term is just minus a, from the a into x square minus a, that means minus a is the constant term on the right hand side. So when you compare all this equation and you put the values and solve them, this is very simple. You will be getting a as minus 1, b as half and c as half. So now put back these values of a, b and c. So our integral on right hand side, which we need to simplify, can be written as minus integral dx upon x plus half into integral dx upon x minus 1 plus half into integral dx upon x plus 1. Now it is just simplification. You know the rule of log. Log of x into y is log x plus log y, and log of x upon y is log x minus log y. So, but first thing is, since you are having half over here, the technique is you just multiply and divide by 2. So what will happen is that half you can take outside and you will be getting the terms as given over here in the bracket. So when I take half outside, it will be minus 2 log mod x plus log of mod of x minus 1 plus log of mod of x plus 1. Now as I told you just previously, log of x minus 1 plus log of x plus 1, that is log of x minus 1 into x plus 1, which is log of x square minus 1, minus 2 into log x, that means it is minus of log x square. As I told you previously, log of x upon y can be written as log x minus log y. So using that rule, you get the simplification. So now what was our equation? Integral dy is equal to integral dx upon x into x square minus 1. Left hand side, you know, integral of 1 dy is y. Right hand side, we just now found the integral. And in this integral, you have c, which is the constant of integration. So suppose if you are asked to find general solution, this is your answer. But they have given that you have to find the particular solution with the given condition. The condition is x is equal to 2. When x is equal to 2, y equal to 0. So just put x equal to 2 and y is equal to 0 in your given general solution. So you will be getting 0 is equal to half log 3 by 4 plus c. Now 3 by 4 log will be positive. So I have written half log 3 by 4 plus c. That means you can write c as minus half log of 3 by 4. So now in your general solution, just put this value of c, it will become a particular solution. So your y is equal to half log mod of x square minus 1 upon x square minus half log of 3 by 4. This is the particular solution with the given condition. Next example, see we are doing different type of examples to get an idea of the variable separable method, which is very useful. Next one, in a bank, principal increases continuously at the rate of R% per year. Find the value of R if rupees 100 doubles itself in 10 years. It is given that log 2 with the base E is 0.6931. So first of all, suppose you are having P, which is the principal amount at any time t. Rate of change means with respect to time means it is dp by t dt. I hope it is clear. Rate of change is always the derivative. So dp by dt, this is given to be increasing continuously at the rate of R% per year. R% means R upon 100. So your rate of change will be that R upon 100 multiplied by the principal amount. So first thing is the formation of a differential equation in these type of examples. So what is a differential equation? dp by dt is equal to R upon 100 into P. Correct? Because it increases R%. The principal increases R%. Now in this differential equation, now our trick, bring the terms having P on one side and T on the another side. So it will be dp by P is equal to R by 100 is a constant term. Rate of interest is constant. So R by 100 into dt. Next, integrate both the sides. So integral of dp by P is equal to R by 100 into integral 1 dt. So on the left hand side, you know 1 upon P. Integral is log P. And on the right hand side, it is R upon 100 into T. Plus your constant of integration. Suppose this constant of integration, I say it is C1. So now the equation which we are having, it has log of P. To just get rid of log, you know that log and exponent are inverse functions. So what you do is you take the exponent, so log will go. So on the left hand side, when you take the exponent, it will be just P. On the right hand side, when you take the exponent, it will be e raised to TR upon 100 into e raised to C1. Okay? Because you know that you are having in the e raised to x plus y is e raised to x into e raised to y. So it is e raised to TR upon 100 plus e raised to C1. Now what I can do is this e raised to C1. Since C1 is a constant, obviously e raised to C1 is also some constant, and I name it as C. So now our simplified equation is P is equal to e raised to TR upon 100 into C. Now what you need to find is a particular solution. That means you need to find the value of C. So what is given, what information is given to us is the value. You are given P is equal to 100. Find the value of R if rupees 100 doubles in 10 years. That means first thing is if initially it is 100 and then it doubles in 10 years. So the initial and final boundary conditions are given to us. In these type of cases, first of all, the initial condition is P is equal to 100. Initial means when T is equal to 0. So first thing is put P is equal to 100 and T is equal to 0. So when you substitute these values, you will be getting C is equal to 100. Why? Because e raised to 0 is 1. So C is equal to P, which is equal to 100. So by using this initial boundary condition, we have obtained the value of C. Next, what the condition given to us is the amount doubles. That means when P becomes 200, in how much time? In 10 years. So when P is equal to 200, T is equal to 10. Already C is 100, we know that. So now we have our equation, only missing term is R, which we need to find out. So our equation is P is equal to e raised to TR upon 100 into C. In that, put the value of P as 200, put the value of T as 10, and put the value of C as 100. So on simplification, you will be getting 200 upon 100, which is 2, is equal to e raised to R by 10. Now again, as I told you, log and exponent, inverse functions. So now when you take log, obviously with the base z on both the sides, it will be log 2 is equal to e raised to R by 10. Log 2 value is given to us 0.6931. So when you take log of exponent, it will become R by 10. So R is equal to 6.931. So the rate at which rupees 100 doubles itself in 10 years is 6.931%. Next, different type of example. In a culture, the bacteria count is found to be 1 lakh. The number is increased by 10% in 2 hours. In how many hours will the count reach 2 lakh if the rate of growth of bacteria is proportional to the number present? Now, first of all, let us evaluate the information which is given to us. First, what is given to us is, suppose you are having the count of bacteria, just call it as x. Let x be the count of bacteria at a given time t. Then dx by dt means its rate of change or rate of growth over here. That is dx by dt. It is proportional to the bacteria. That means it is proportional to x. So when two quantities are directly proportional, how do you write it? Dx by dt is equal to some constant k into x. Correct? So we have an equation dx by dt is equal to k into x for some constant k. Now you apply what I told you is, first of all you need to get the differential equation. After getting it, you just apply the technique. You just bring the term having x on one side and others on the other side. So dx by x is equal to k dt. Now next step, you know, it is integrating. Integral of dx by x is log x, log mod x, and on the right hand side integral of k dt means k is constant, so k into t. So our equation is log mod x is equal to kt plus c. This is the first step. Now see, since this is a confusing type of example, what we do is we first just list down all the information. So it will be very easy for you to find the constants. It is given to us, three things are given. Initially, the count of bacteria is 1 lakh. That means when t is equal to 0, the bacteria is 1 lakh. Next thing, it is given to us that the number is increased by 10% in 2 hours. So when t is equal to 2, what will be the count of bacteria? Originally 1 lakh plus 10% of 1 lakh. Correct? So it will be 10,000. So 1 lakh plus 10,000 is 1 lakh 10,000. Next, what we need to find is that when will your count reach 2 lakh? That means you have to find the value of t when the count of bacteria is 2 lakh. So these three things are given to us. Now, first of all, we use the first condition. What is the first condition? When t equal to 0, x is 1 lakh. So in our equation, put t equal to 0 and x as 1 lakh. You will be getting the value of c as log of 1 lakh. Correct? See, our equation log mod x plus kt is equal, log mod x is equal to kt plus c. It contains two constants k and c. From that we have already found the value of c. Next is we need to find the value of k. So the next condition given to us is when t equal to 2, x is equal to 1 lakh 10,000. So now in our given equation, already c is log of 1 lakh, and put t equal to 2, put x is equal to 1 lakh 10,000, you will get this equation. So when you simplify it, you will be getting the value of k as half of log of 11 by 10. So now what is our main equation? Log mod x is equal to k into t. That means half log of 11 by 10 into t plus c means plus log of 1 lakh. Now what we need to find is the value of t when x is 2 lakh. So in our given equation, just put the value of x as 2 lakh. So the only unknown is t. Simplify the equation. I have shown the simplification over here. T is 2 log 2 upon log of 11 by 10. So we have found the value of t, which is 2 log 2 upon log of 11 by 10 hours. Since the variable separable method is an important method, let us solve one more example. The volume of a spherical balloon being inflated changes at a constant rate. If initially its radius is 3 units and after 3 seconds it is 6 units, find the radius of balloon after t seconds. Now the data for the volume, that means the volume of a spherical balloon changes. That means first of all, what is the formula for volume of a sphere? It is V is equal to 4 upon 3 pi r cube, where r is the radius. So what is given to us is rate of change of volume, means dV by dt. This rate increases at a constant rate. That means this is equal to some constant k. So first thing is our differential equation, which is dV by dt is equal to k, where k is a constant. Correct? Now, what is the next step? Bring the terms having v on one side and t on another side. So it is integral of dV is equal to k into integral of dt. Simple equation. Integrate on both the sides. After integrating on both the sides, what do you get? V is equal to kt plus c. So our equation is, but what is V? V is 4 upon 3 pi r cube. Since the data is given in the form of radius, we need to write this equation in the form containing r. So 4 upon 3 pi r cube is equal to kt plus c. Now what conditions are given over here? I told you previously, if you just list it in the form of a table, it will become very easy for you to get the constants. Again, in our equation 1, there are two constants which we need to find out, which are k and c. So first condition is initially its radius is 3 units, means when t equal to 0, r equal to 3. After 3 seconds means when t is equal to 3, r becomes 6. And next is you need to find the value of r at a given time t. So first, to find the constant c, put t equal to 0 and r is equal to 3. So it will give you c as 36 pi. We have found c, which is 36 pi. Now next constant we need to find is k. So next information which is given to us is when t equal to 3, r equal to 6. So put the value of t as 3 and r is equal to 6. So when you simplify this, you will be getting the value of k as 84 pi. So now our main equation is 4 upon 3 pi r cube is equal to 84 pi into t plus 36 pi. Now since we want to just simplify, just divide the whole equation by 4 pi. So you will be getting r cube by 3 is equal to 21t plus 9. Now in this equation, what they are saying is you just find the value of r, means make r as the subject of formula in terms of t. So r cube is equal to 63t plus 27. So r will be equal to 63t plus 27 whole raised to 1 upon 3. So students, in this video we have seen order and degree of a differential equation, general and particular solution, and a very important method, variable separable method, to solve a first order first degree differential equation. In the next video we are going to study other methods to solve the differential equation. So please like and share the video and subscribe to the channel.